video contains the solutions for, well, I'm going to say the first two. We'll see how far we get, but probably just the first two of the Chapter 10 Free Response Practice. And we'll call this Chapter 10 Free Response Practice 1, because we might have another one of these. Well, we will have another one of these. Okay, so this one we want to find, they're giving us a series here, given by this, and they gave us the first bunch of terms. And we want to find the interval of convergence for this series. And look, hey, the AP folks are using Maclaurin. This might be an older problem. I don't think they do that much anymore, but it contradicts what I said, so sorry about that. So let's see, for part A, let's do the interval of convergence. We use the ratio test. Let's go ahead and tell them that we're going to do that. And we will write the limit as n approaches infinity of the n plus 1 term. That would be 2x to the n plus 2 over n plus 2 divided by the nth term. That looks like that. Now it looks like I have one extra 2x on the top, and that does not belong inside the limit. And then I've got n plus 1 over n plus 2. That limit is just equal to 1, so that's 2x. So that means we have to sandwich 2x in between 1 and negative 1, dividing all of those pieces by 2. We get this interval. But we must check the endpoints. So we will check negative 1/2. When you plug negative 1/2 in here for x, 2 times negative 1/2 is negative 1 to the n plus 1, so it's going to alternate over n plus 1. And that, if you want to write out the first few terms, going from 0 to infinity, plug 0 in, that's going to be positive, and positive 1 over 0 plus 1, that's 1, and then minus 1/2 plus 1/3. That's the alternating harmonic series that converges. Because terms go to 0 and it alternates, right? That's all you need for an alternating series. Now we need to check 1/2. When you plug 1/2 in here, we get 2 times 1/2 is just 1. So that's 1 to the n plus 1. Of course, that's just 1 all the time for n plus 1, starting at 0. That's going to give us the harmonic series that diverges, because it's the harmonic series. Everybody knows that diverges. Come on. So it looks like our interval is going to be negative 1/2, 1/2. That's part A. Part B, find the first 4 terms and the general term of the Maclaurin series for the derivative of this. Well, look, they wrote out the terms. The first 4 terms are going to be much easier than that. So the derivative of this is 2. The derivative of this is, let's not simplify, that might help us find the general term, is 8x over 2. The derivative of this is 3 times, actually I should probably write that as 2 times 4, right, so I can see what all the numbers are doing. And then that's going to be 3 times 8 over 3 times x squared. And that's going to be 4 times 16 x to the 4th over 4. And you can actually leave your first 4 terms like that, but I think clearly we're getting canceling on all those. So I'm going to go ahead and write my answer like 2 plus 4x plus 8x squared plus 16x. Oops, I wrote to the fourth there. That should be cubed. Taking the derivative. And then what's the nth term? Well, it looks like these are powers of 2. That's 2 to the, if I wanted to start at 0, if that was the 0th term, that would be 2 to the n plus 1. That's the first power of 2, times x to the n, because x to the 0 would just be 1, and then that would be the first, second, third. So that's the n term right there. They don't alternate. So there you go. There's part B. Part C. Use the Maclaurin series you found in part B to find the value of f prime of negative 1/3. All right, so let's plug negative 1/3 in here. So we get 2 plus 4 times negative 1/3 plus 8 times negative 1/3 squared plus 16 times negative 1/3 cubed, and so on. So let's see, what kind of series is this? Well, it looks like it's actually, since I'm multiplying by 2 every time here and then multiplying by negative 1/3 every time also, it looks like it's actually a geometric series where the first term is 2, and I'm multiplying by 2 every time on the top. Multiplier is 2 on the top and 3 on the bottom, or like 1/3, negative 1/3, so the multiplier is negative 2/3. So that means the sum is first term over 1 minus the multiplier, right? Sorry, that's a little bit off the screen there. There we go. So that's 2 divided by 1 plus 2/3 is 5/3, and that's the same as 2 times 3/5, or 6/5. 1.2. Alright, that wasn't too bad, and that took a little less than 8 minutes. You can cruise through these problems if you know what you're doing. Let's try the next one. See if we can make as quick work of that. Alright, the Maclaurin, there we go, saying Maclaurin again. The Maclaurin series for the natural log of 1 over 1 minus x is this, with an interval of convergence, this. Find the Maclaurin series for this and determine the interval of convergence. Alright, let's see. Well, all we're doing here is replacing x with negative 3x, right? So I just have to replace the x here with negative 3x, and that's it. So that Maclaurin series, part A, instead of being the sum from n equals 1 to infinity of x to the n, we're replacing the x with negative 3x to the n over n. And since the interval of convergence was negative 1 less than or equal to x, I'm replacing that x with a negative 3x. This is just substitution, that's all. Teach an Algebra 1 kid to do this. Then I divide everything by negative 3. That's going to flip all the signs. That's going to give me 1/3 with the equal sign, x in the middle, and negative 1/3 here. So there's your series, there's your interval of convergence, all just by substitution. Part B, what's the value of this? Well, if you look at this, it would appear that what they have done is plugged in negative 1 for x. So if you can plug in, I mean this is like an equal sign, right? So so long as -1 is in this interval of convergence, which it is, I can just plug in -1 here. That means I can plug in -1 here. So that's just natural log of 1 minus 1, 1 over 1 minus plugging in -1 here. That's just natural log of 1 over 1 minus -1, which is the natural log of 1/2. That's all there is to that. These are interesting questions about p-series and your knowledge of those. So let's see if we can figure this stuff out. So part C, I'm going to give a value of p so that this converges but this diverges. Well, let's focus on those one at a time. This is an alternating p-series. So for what kinds of p's will this converge? Well, it's alternating, so all that has to happen is the terms here have to keep getting bigger on the bottom, which will make the whole thing get smaller. And that means the p doesn't have to be greater than 1, it just has to be greater than 0. Why not negative p's? If you start putting in negative p's, like -1, say, that flips these up to the top, right? That's what negative exponents do, and that's going to result in things getting bigger and bigger on the top. So that's no good. You're never going to be able to get a p-series to converge where the p is less than 0, even if it alternates. Not possible, because the terms will start blowing up. So for this to converge, p has to be greater than 0. Now this, if this is a regular p-series, for a regular p-series to converge, the p has to be greater than 1, right? Right? So that means p has to be greater than 1/2. Correct? Right? That exponent has to be greater than 1, so that means p has to be greater than 1/2. So we can give any value greater than 1/2 will work for this. Give a value of p, so I could say so they said actually give a value, so I could say p equals 1. Just pick anything that's bigger than 0 and bigger than 1/2. So p could be anything bigger than 1/2, but you're supposed to pick one. And give a reason why your value of p is correct. So I'll pick p equals 1. So for that, we end up with these two series. This one would look like -1 to the n over n, which is the alternating harmonic series which converges. And the other one would be, see if that would be 1 over n squared if p was 1, right? Which is p series where p is greater than 1. So which converges. Right, but lots of possible correct answers. All right, now D, variation on the same thing. Give a value of p such that this one diverges, but this one converges. So we'll look at them one at a time again. For this to diverge, and since it's a p series, p could be anything less than or equal to 1, right? It's the opposite of making it converge. So the opposite of being greater than 1, if it was 1, it would be the harmonic series. Anything less than 1, it will diverge, including negative numbers, right? That'll just diverge even more. All right, now what about this? If we want this to converge, then this is a p series. Oh, wait a minute. Oops, I'm looking at C again. They wanted this to diverge. So that means if we want this to diverge, I messed this up, didn't I? Then it has to be the opposite. I just realized when I was doing this. So we'd have to make it a p series that diverges, which means 2p would have to be less than or equal to 1, which means p has to be less than or equal to 1/2. So scratch that 1. We need to be in between 0 and less than or equal to 1/2. So I could pick 1/2. So let's try that instead. So if p was 1/2, then this would be, so that's not the alternating harmonic series, it's an alternating p series, and that's going to converge because the terms are approaching 0 and it alternates. And then this would be 2 times 1/2 would be 1, and that is p series where p is equal to 1, which diverges. That's, in other words, that's the harmonic series. Sorry about that error there. So the logic was correct, I just misread the problem. So 1/2, but anything in between 0 and 1/2. Any value in that interval would have been a correct answer. Alright, try not to mess this one up. So here, if we want this to diverge, then that's a p series, so I need likewise for the p to be less than or equal to 1. Right? If I want this to converge, then 2p has to be greater than 1, right? The exponent would have to be greater than 1, which means p has to be greater than 1/2. So I need to be in between 1/2 and 1, somewhere on this interval from 1/2. Oops, open 1/2 to closed on 1. So let's pick 1, say, but you could pick anything here. Not 1/2, right? It's open there. You could pick 1. Let's pick p equals 1. If you pick p equals 1, then the first series would be, it's 1 over n to the p, so that would be 1 over n, which is the harmonic series, which diverges. And the second one would be, sorry, I'm getting lazy here, leaving out the details. Not that it matters where you start, but, and then this one would be 1 over n squared, which is a p series where p is greater than 1, and that converges. Remember why that converges? How do we know this stuff about p series? By the integral test. Probably don't have to say that. We'll check it out in the rubric, but that's why, that's how we know the, oops, there we go. That's how we know the p-series information that we do. That's good. I think I'm going to stop there, and we'll put the other two in a second video.